Cauchy's general principle of convergence, and it states that the infinite series UN converges uniformly on E if and only if, given epsilon positive, there exists a positive integer n such that the mod of summation r starts from n plus 1 to m on urx is strictly less than epsilon. For all n greater than equal to n, for all x belonging to E where this m is strictly greater than n. This is very important. So it is again a two-way proof. First, let's suppose that the infinite series is converging uniformly on E and we have to prove this result, and then the other way, right? Okay, let's start with the proof. Suppose the infinite series UN converges uniformly on E, right? Then the result states that the sum of infinite series converges uniformly on E if the finite sum, let's say f1 plus f2 plus f3 up to fn, converges uniformly on E. And let's name this finite sum to be as Snx. Alright, so suppose the infinite series UN converges uniformly on E. So by definition, let Snx, that is equal to u1x, the finite series, u2x plus u3x up to so on unx. Then this Sn is converging to, let's say, U uniformly on E. This is the result. And this result is also mentioned in the previous content. Now because this finite sum is converging to U uniformly on E, then I am going to use here the Cauchy's criterion for uniform convergence. That states, the sequence of function fn converges uniformly on E if and only if, for every epsilon positive, there exists a positive integer n that depends upon epsilon only, such that for all x belonging to E, the mod of fnx minus fmx is strictly less than epsilon for m n greater than equal to n. So we are going to use this Cauchy's criterion for uniform convergence in the next step, because here in this criterion they are saying that the sequence of functions fn converges uniformly on E, and we have taken this sequence of function that is converging uniformly on E, right? So let's use this result. Therefore, for given epsilon positive, there exists a positive integer n such that mod of smx minus snx, here I am using smx minus snx instead of fnx minus fmx because we have taken the sequence in Sn. So this is strictly less than epsilon for m. Now m here, it is given to us that m is strictly greater than n. So we should write m strictly greater than n, and that is greater than equal to n. Right? Okay. Please notice this carefully, because m is strictly greater than n. Right? Now if Snx, we have taken this to be as u1x, the finite series, u2x plus up to so on unx, right? Then what is smx? It should be u1x plus u2x plus up to so on, of course, unx. And because m is strictly greater than n, so let's continue this, plus un plus 1x plus un plus 2x up to so on up to umx, right? So that if I take the difference of these two series, that is, what is the difference? This complete is your Snx, right? So if I subtract this Snx from this Smx, what I'm getting, the remaining terms to be, this all are cancelled out, and the remaining terms left as un plus 1x plus un plus 2x up to umx, right? Please notice this. And let's use this over here in the next step. So this implies the mod of Smx minus Snx is un plus 1x plus un plus 2x up to so on umx. Very fine. This is strictly less than epsilon for n greater than equal to n and x belonging to E. Please write here also x belonging to E. Very important. So this implies this can be written as, these series can be written as in a summation form as urx, where r is starting from n plus 1 up to m. So this is strictly less than epsilon for n greater than equal to n and x belonging to E. So hence first way is done, right? Now the converse. Converse, this is given and we have to reach back that series is converging uniformly on E, right? Okay. So conversely, suppose that the mod of summation urx, where r is starting from n plus 1 to m, this is strictly less than epsilon for n greater than equal to n and x belonging to E. Which implies, can I write this as, just we have to reverse the steps now. So can I write this as, okay, so r is starting from n plus 1, so write this as, just open the summation, un plus 1x plus un plus 2x, so on up to umx. Strictly less than epsilon for n greater than equal to n and x belonging to E. And then next step, yes, write this as, very good, Smx minus Snx. Strictly less than epsilon for m greater than n greater than equal to n. Very, very important. X belonging to E. Where we should mention here that Snx is equal to u1x plus u2x plus u3x up to so on unx. Right? Now this epsilon was arbitrary, but epsilon was arbitrary. Right? So therefore, the sequence Sn converges uniformly on E by reason using Cauchy's criterion for uniform convergence. So thus, the infinite series un n starting from 1 to infinity converges uniformly on E by definition. Hence, the second way also proved. Alright, thank you, stay blessed.